So, in this lesson, we're going to look at experiment L1. L1 is an experiment to find the focal length of a concave mirror. So what I want you to do is, I want you to go to your notes. We're in lesson number 3 at the moment, on light and sound, reflection 2, and go to the experiment at the very end, towards the end of those sets of notes. So here's my experiment, L1, experiment to measure the focal length of a concave mirror. Now, there's 3 important things you've got to do when you do experiments. First essential thing is know a label diagram of each experiment. My diagrams are dead simple. Anybody could draw them. So learn a label diagram of every single experiment. The next thing you need to be able to do is do the calculation. The calculation might involve a formula or a graph or maybe both. And finally, know some sources of errors and precautions. I call them experimental details. What about the method? Do I have to learn that method off? No, just read it. Just be familiar with the method. You'll never have to write out the method when you do this experiment. Now, when I explain these experiments, I'll always do them by using a Leaving Cert question. So the Leaving Cert question I'm going to use is from Leaving Cert 2021. Question number 2. So there's my experiment. So it says, in an experiment to determine the focal length of a concave mirror, a student first made an approximate measurement of the focal length of the mirror. He then measured the image distance V for 2 different object distances U. The results, the data, is shown as follows. What's the first thing they're asking me to do? Why did the student first make an approximate measurement of the focal length? Well, why do I need to make an approximate measurement of the focal length F? There's 9 marks for this. Well, you should know this from studying the lesson. If you put the object inside the focus, what do you end up getting? You end up getting a virtual image. And what can we say about virtual images? They cannot be formed on screens. So therefore, you will not see them. So you will find an approximate value of F, let's say it's 10 centimeters, and then you will make sure that your first distance is outside 10 centimeters so you can form the image on the screen. So basically, I'm saying here, why did I need to make that approximate measurement of F? To ensure the object O is outside the focal length F to get a real image. That's fine. So 9 marks for that. Second part of the question. They're asking me, how did the student determine the image positions? Well, that's easy enough. I go back to my diagram of the experiment here. I determine the image position by moving the screen, which is here, in and out, until a sharp image is formed. We'll draw the diagram in a few minutes, but that's essentially all they are asking there. So the question is, how do I capture the image position? Well, move the screen. Until a sharp image is formed. So 3 marks for saying that. Right, moving on the question. The next part of the question. They're asking me, part 3, draw a label diagram of how the apparatus was arranged. Look, they're just saying draw a label diagram. You don't have to say anything about it. You don't have to describe how the apparatus was set up. So always read the words very, very carefully. So let me draw my label diagram. Now, my label diagrams are extraordinarily easy. I can't draw. and yet I can draw these fairly neatly. So part 3, 4 marks for drawing my label diagram. I'm going to start off by drawing an optical bench. Sounds a bit fancy, but it's just a ruler that you slide up and down your mirrors and your lenses and your screens. So label everything. So there's my optical bench. I now want to put the apparatus on it. So I'm going to put a mirror on it. So here's my concave mirror. A little stand to hold it up. I want to label that. I'm going to put in a light source. Like some students use ray boxes, I'm going to keep this as simple as possible. Here's my light source. It's just a tiny little bulb on a stand. And that light source will represent the object. Probably the filament of the inside the bulb will represent the object. So there's my light source, which will be my object O. And then finally, I want to capture that, the image of that object on a screen. So I'm going to put in a screen here, which is just a piece of cardboard, really, on a stand. So there's my screen. Label that. And my image will be captured there by moving it in and out. So look, very, very simple. Every diagram should be like that. Flat. Don't be drawing some wonderful art, because you're only getting 4 marks for this anyway. You should have all this done in about 30 seconds. Indicate U and V, the object distance and the image distance on that diagram. This is for 6 marks. Well, the object distance is the distance of the object to the mirror. So from here, mirror to the object, that there represents my object distance, U. Image distance is the distance from the image, which is on the screen, all the way back to the mirror. So be careful of that. Some students put V going from there to there. It's the distance from where the image is formed on the screen to the mirror. So 6 marks for that. So back to my question. Part 5. It says use all of the data to calculate the focal length of the mirror. So there's 2 ways to do the calculation. One is using the formula, and the other is using the graph. Well, if they don't ask you to use a graph, which they rarely do, by the way, then I'll definitely go for the formula. Definitely go for the formula. Much, much easier. So there's my table of results. So I've got to use all of the data in there to get my value of F. Well, what's your mirror formula? Your mirror formula is 1 over U plus 1 over V equals 1 over F. I want to write that down in terms of F. Well, let me turn the right-hand side upside down to get F. You can't turn each of those individually upside down because of that plus there. So I'm going to turn the whole thing upside down. Let me wrap the 1 over U plus 1 over V in brackets. And the way I say mathematically to turn it upside down is to take the reciprocal of it, or put that bracket to the power of -1. That's turning it upside down. So now, let me work out using all of the data. So the first set of data when U is 20 centimeters, V is 31.2. So we call that focal length F1. So F1 is equal to 1 over U, which is 1 over 20, plus 1 over V, which is 1 over 31.2, to the power of -1. So let's put that to 2 decimal places, because it's not my final answer. Maybe I'll put my final answer to 1 decimal place. But before that, I'll go 2 decimal places. So you've got your new calculator. So get your calculator out. And we'll do that calculation. So bracket, fraction button, 1 over 20 plus fraction button, 1 over 31.2 close bracket. Now I want to put that to the power of minus 1. Well, I can press shift. This button here will give me to the power of minus 1. And then I execute and I get a fraction. I want that to be in decimal form. So I'm going to press format. I want it to be in decimal form. Execute. And I get 12.1875, 2 decimal places. 12.19. So the result of that is 12.19 centimeters. And you know what? It was okay to leave everything in centimeters and my answers in centimeters. Now let's work out F2. So put in the next set of results. 1 over 25 plus 1 over 23.2. All to the power of minus 1. You put that into your calculator. You don't need me to do it for you. You just work ahead and do that yourself. And the answer you will get to 2 decimal places is 12.03 centimeters. So I'm using all the data. Now, of course, the focal length should be the same, no matter what measurements you take. So therefore, now I'm going to get an average of those two. So my average F would be 12.19. That's F1 plus 12.03. That's F2. And divide that by 2 to get the average focal length. And the average focal length will give me an answer. I'll go to 1 decimal place now of 12.1 centimeters. Right, so let's finish off the question. On the next page, another student carried out this experiment, but she measured the image distance V for 6 different object distances U. She then drew a graph and used the graph to calculate the focal length. So they're asking me to sketch a suitable graph. Now, they rarely ask you to draw the graph. Here, they're just asking you to sketch it. But you should know this. And then in part 7, they're asking me, how can you calculate the focal length from that graph? Well, I do explain this in the notes on the experiment. So these are the notes of that experiment, experiment L1. And there's 2 ways to do the calculation. One way is the formula. Yeah, I'll always do that. If they don't ask for a particular way, always go to the formula. It's dead easy. And the other way is the graph. And the graph is trickier. There's the sketch we're talking about. You're going to put 1 over U. 1 over U is 1 over centimeters. So the units are centimeters to the power of minus 1. And I'm going to put 1 over V here. So let me show you that in more detail on the board. So they're asking me to draw the suitable graph. So just a sketch of it, because we don't have any results for it. So I've got my axes. And I'm going to put 1 over U on the x-axis. And its units are centimeters to the power of minus 1. And I'm going to put 1 over V here. Centimeters to the power of minus 1. And the kind of graph you get is a graph that goes like this. It's a graph that's shaped like that. And these points here where it cuts the graph, they're called the intercepts. So that's the suitable graph that we're talking about. The other part they're asking me to do is find F from the graph. Well, the way you find f from the graph is if you read off what the intercepts are. That distance there from the origin to that intercept, that equals 1 over f. It's not hard to explain why that's the case, but I'm not going to do it here. And this intercept here is also 1 over f. So basically, what you need to do to find f from the graph, you find values for 1 over f. You'll average those values, and then you'll get your value of f by getting the reciprocal, turning it upside down, of that value of f. They're just asking me to explain it from the graph. There's quite a lot of marks for that last part. 9 marks for drawing the suitable graph, and then 6 marks for telling me how do I find f from that graph. Okay, so that's the end of that particular experiment.